This is question 20 on problem solving from the 2018 ECAA. So we're told that a train service runs from station A to station C, with some of the trains stopping at station B as well. And the distance between A and C is 18 miles, and between B and C is 7 miles. So if trains leave A and C simultaneously and travel at 60 miles an hour, if the train from A stops at B for 2 minutes, but the train from C does not, it just carries on past B, then which of these graphs shows the distance between the two trains from departure to arrival? Now firstly, let's try and work out what the axes on the graph represent. So all of them have this sort of V shape, and we know the trains are going to go towards each other and cross at some point. And so this y-axis must be the distance, because we know this is going to go to 0 at the point where they cross, then go back to where it started, which is the maximum distance between A and C. And what's on the x-axis? So this is from departure to arrival, so this is the time. So how do we work out which graph shows our journey? Well, let's fill in the rest of this diagram. So what's the distance from A to B? So 18 miles minus 7 miles is 11 miles. And so what's going to happen at the start of the journey? We know both trains are going at 60 miles an hour, one going from A towards B, one going from C towards B. And so at the start, they're going to be going at a constant speed towards each other, and so the distance is going to go down at a constant rate. So what's the first point of interest? Well, if they're going at the same speed, and C is closer to B than A is, then the train going from C is going to approach B first. But we know that this train does not stop at B, it just goes past it. So what's going to happen? So the train from C is going to reach the midpoint at the 9-mile mark, and train A is going to reach this midpoint, and they're going to pass each other. So that means the first part of the graph is going to be a constant downward slope until the trains cross, because we know neither of them stop at any point before they cross. So that rules out this graph, because you see it has a kink before they reach each other. And similarly, this graph and this graph. We need a graph that has a straight line down to where the trains meet, which only two of them do. So what happens after they meet? Well, train A is going to keep going and reach B, and we know that this train stops at B for 2 minutes, and train C just carries on towards A. So what's the graph going to look like when train A is stopped? Well, we've got the choice of the distance stopping, changing altogether, or in changing more slowly. Which one's it going to be? Well, while train A is stopped at B, train C is still moving. So the distance is going to keep increasing, just at a slightly slower rate. So that means this one is wrong, and this one is correct. And what's meant by this kink at the top? Well, if they're going at the same speed, the same distance, but one train is stopping and the other's not, then train C is going to arrive at A 2 minutes before train A arrives at C. And that's what this last kink means. So this is the final answer, which corresponds to E on the question paper.